Welcome to Lesson 9 in Solution Equilibrium. This goes along with the SE9 and SE10 assignments on flowcharts. A flowchart shows each step of a process, outlining three things: what we start with, what we are adding, and what we end up with. I'm going to show you what a flowchart looks like. Don't copy it down. I'm just going to show you so you can budget for space when writing down the example. And to make our flowchart, we are going to have to use the solubility data table that is located on the green sheet and conveniently also located on the pink sheet. In this unit, we will use flowcharts to show how a number of ions dissolved in the same solution can be isolated. Right now, all four of these cations are dissolved in water. We want to consult the ion chart to determine an anion that can be added to the solution that would form a solid with only one of the cations and would leave the other three in solution. A chemist would then put the solution in a centrifuge. It would spin the sample around at great speed, forcing the solids to collect at the bottom of the test tube. They would then decant the water off the top and move on to the next step. So after spinning it in the centrifuge, this is what it would look like. And when we had those four cations, if we added an anion that would form just one solid, that solid would be sitting on the very bottom of that test tube. We would then decant, which means pour off the liquid from the top, which now only contains three cations. So I've got copper 1 ion, beryllium ion, barium ion, and potassium ion. And we want to add an anion that will form a solid with only one of these four cations. So we're going to work our way through the chart. Now, I'm going to color code these as we go through as either blue, red, or green. If it's green, it's good because it only makes one solid. But if I mark it as red, it will not work for us because it makes more than one solid with the cations that we have. If I mark it in blue, that means it doesn't make any solids with the cations that we have. So if we look at nitrate first, it says that essentially all cations mixed with nitrate is soluble. So we'll mark that in blue because it would not form a solid with any of the four cations that we have. Now let's look at acetate. Well, copper 1 is in the all others category. Beryllium is in the all others category. So is barium ion and potassium ion. The only thing that acetate makes a solid with is silver. So since acetate does not make a solid with any of the cations that we presently have, we will also mark that in blue. Now with the halides of iodide, chloride, or bromide, copper 1 ion is low soluble, so it will form a solid with copper 1. Beryllium, barium, and potassium ions all fall into the all others category, which are soluble. So that means I could use a halide in my first step because it forms just one solid, a solid with copper 1 ion, but not forming a solid with any of the other cations that I have. If I look at sulfate, well, sulfate copper 1 ion is in the all others category. Beryllium is in the all others category. Barium ion is low soluble, so that will form a solid with barium. Potassium is in the all others category, so that means the addition of sulfate would produce just one solid. So we could start with sulfate, take out barium. Now if we look at sulfide, well, sulfide, copper 1 ion is in the all others category. Beryllium is in the soluble category, so is barium, and so is potassium. So we could use sulfide because it does form one solid, a solid with copper 1 ion. Now if we looked at hydroxide, if we use hydroxide in our first step, well, Cu plus is in the all others category, so it would form a solid with copper 1. It would also form a solid with Be2 plus. It would not form a solid with barium ion or potassium ion. So if we used hydroxide in our first step, we would get the entire question wrong because that would form two solids. And again, we're only allowed to form one solid at a time. Now, if I look at the last one, carbonate, phosphate, and sulfite, copper 1 is in the all others category. So is beryllium, barium. Those are all in the all others category. Potassium is in the soluble category. So that means if we added either carbonate, phosphate, or sulfite, we would have 3 solids form. And we don't want that either because we're only allowed to form 1 solid at a time. Now note as we work our way down the chart, it started off with nitrate and acetate and the halides, which form very few solids. So it's easier for the chart to list who they make solids with rather than who they do not make solids with. As we go down the chart though, going from sulfate to sulfide, the soluble, low soluble flip because at that point, sulfide, hydroxide, carbonate, phosphate, and sulfite produce many solids. So it's easier for the chart to tell us who they do not form solids with. So if I was starting off this question, well, I couldn't use nitrate or acetate because they don't form any solids with the ions that I presently have. When it comes to the halides or sulfide, well, I could start off with a halide or a sulfide to take out copper 1 ion. Or I could start with sulfate and take out barium ion. So that means that my flowchart might look different than someone else's flowchart. They might use a different anion off the top, and that ion might wind up taking out a different cation off the top. So that means there are several different plausible solutions to this problem. When we get down to the bottom, hydroxide, carbonate, phosphate, and sulfite all cannot be used because they would form more than 1 solid. So how would I do this question? Well, I first would write down the 4 cations that I have, and then I'd have to determine what can I add that would only make 1 solid. Now, we just discussed that nitrate doesn't form a solid with anybody, so I'm just going to cross nitrate out lightly with my pencil. And then when I got to acetate, we said the copper 1, beryllium, barium, and potassium are all soluble with acetate, so acetate also will not form any solid, so I will cross that out. When I look at the halides, I got iodide, chloride, bromide. Well, Cu plus will form a solid. Beryllium, barium, and potassium will not. So we said we could start with a halide. So I'm going to use Cl minus. Notice how I write Cl minus and I put it over the arrow. That means that I would be adding Cl minus, and when Cl minus is added, it would form the solid of CuCl. So CuCl has now been pulled out of solution, and the rest of the cations will flush down. So Be2+, Ba2+, and K+, flush down to the next round. Now since I used the halide, I'm now going to cross that out with pencil because, well, it wouldn't form a solid with the 3 remaining cations that I have. Now, what could be used to remove one of the 3 ions that still remain in solution? Well, if I look at sulfate now, because I've already eliminated nitrate, acetate, and the halides as usable, so I'll go down to sulfate. Sulfate, well, Be2+ is in the all others category. Ba2+ says it's low soluble, and K+ is in the all others category, so it is soluble. So I could use sulfate in my next step because it will form a solid with barium. So I'll draw my arrows. I'm adding SO4 and SO4 will form a solid with barium, making BaSO4. Now Be2+ and K+ will flush down. Now that I use sulfate, I will also cross sulfate off the list. What could be used to remove one of the 2 ions that still remain in solution? Well, look at sulfide now. Be2+ is soluble, K+ is soluble, so it will not form a solid with the 2 cations that remain. So I'll cross that out, and I'll move down to now hydroxide. So Be2+ is in the all others category, and K+, it says, is soluble. So that means if I add hydroxide, it will form a solid with the beryllium cation. So I'll draw my arrows. I'm adding hydroxide. It's going to form a solid with beryllium, so Be bracket OH bracket 2, and K+ will remain in solution. My flowchart is complete. Keep the following in mind. Your flowcharts should be neat, and when complete, they need to look like mine did in the example. Charges are written where required. Cation is always written before the anion in a formula, and formulas have to be written correctly. Charges balance out. In order to make the answer key possible, as there are a near infinite number of combinations in which these anions could be separated, you have been limited to using only certain cations. In the examples, these are copper 1, magnesium, silver, lead 2, strontium, calcium, and thallium ions. The answer key is written in a way that will show you all the possible solutions to the flowchart problem, as there are often more than one correct flowchart for each problem. Here, in this question, there were 3 possible solutions. Someone may first take out thallium by adding sulfide or a halide, then calcium with sulfate, and then take out magnesium with hydroxide, sulfite, carbonate, or phosphate. Or they could have taken out calcium first with sulfate, then magnesium with hydroxide, then thallium with sulfide, a halide, or sulfite, carbonate, or phosphate. Or they could have started with calcium with sulfate again, but then taken out thallium second using sulfide or a halide, and then take out magnesium using hydroxide, sulfite, carbonate, or phosphate. Many years ago, a group of students found it easiest to draw a chart when they make a flow chart for separating anions. This is because the solubility chart is organized by anions instead of cations. When students do this, their average on a quiz and the exam is always higher than those that did not make the chart. So to make the chart, you'd want to sketch out what we have on the left-hand side. On the far left are the 4 anions that we're trying to separate. At the top, I've written all the cations that we are allowed to use. So if I look at the halides first, well, Cu plus is low soluble, so I will write a solid in the box where Cu plus and Cl minus meet. Mg2 plus is soluble, so I'll just put a dash. Ag plus is low soluble, so it would form a solid, so I'll put a solid in the box. Pb2 plus is also low soluble, so I'll put solid in the box. Strontium is in the all others category, which is soluble, so I'll put a dash. Calcium is also soluble, and thallium, it says, is low soluble, so I'll put a solid in that box. When I look at the nitrates, it says essentially all are soluble, so I'll put dashes in all those boxes. Now for sulfate. Cu plus is in the all others category, so it's soluble, so I'll put in a dash. Mg2 plus is also in the all others category, which is soluble, so I put in another dash. Ag plus is listed as low soluble, so I'll put a solid in the box. Pb2 plus also low soluble, so I'll write solid. Sr2 plus also low soluble, so I'll put solid. Calcium ion also low soluble, so I'll put S for solid. And then Tl plus is in the soluble category, all others, so I'll put a dash. Now for carbonate, phosphate, and sulfite. Cu plus, all others, says it's low soluble, so I'll put an S in the box. Mg2 plus, also all others, low soluble, so I put an S in the box. Ag plus, also all others, so low soluble, so I put an S in the box. Pb2 plus, also low soluble, so I put an S in the box. Strontium, same thing. Calcium, same thing again. And then thallium, once again, also low soluble. So carbonate will form a solid with any one of the cations that we have. So I'll write down my anions: chloride, nitrate, sulfate, and carbonate. Now I'm going to use the cations to separate these anions, so I can add any one of these cations. So let's work our way down the list until we hit something that will work. So copper 1, well, that forms 2 solids, and that's too many. Magnesium that forms one solid. Perfect. Let's use that. I'll draw my arrows in. I'm adding Mg2+. It's going to make a solid with carbonate, so MgCO3 is my solid. And then I'll flush down the rest of the anions, chloride, nitrate, and sulfate. Now, carbonate has been removed, so I'll just strike that out. So let's start over again. Right, so let's work our way down the list again. Cu+, which we couldn't use before, we can now use since carbonate has been removed. So let's use copper 1 to take out chloride. So I'll draw my arrows. I'll put Cu+ over top of the arrow. It forms a solid with Cl-, or a solid is CuCl. And we'll flush down the rest of those anions, sulfate and nitrate. Since chloride has been removed, let's cross that out. So we'll work our way down the list. Copper 1, magnesium, they don't form solids, but silver does form one solid. If we used it first, we would have been in trouble because it would make 3 solids, and that's way too many because we're only allowed to make one at a time. So now silver will make a solid with sulfate, but nothing else. So let's draw our lines in here. I'm going to be adding Ag+. It's going to make a solid with sulfate, so the solid will be Ag2SO4, and nitrate will be left behind. And that's it. That's the whole thing. You're ready to start flowing through this assignment. Get it?